Today we are going to cover the unconventional machining process part 4. In this part we will be discussing about two processes: LBM, that is laser beam machining, and EBM, that is electron beam machining. Both come under the category of thermal unconventional machining. So let's start the lecture. First we will be discussing about laser beam machining. Now what is laser beam machining? Laser beam machining, first of all we should know what is laser. So laser is light amplification by stimulated emission of radiation. So this laser energy will be used in machining the workpiece or the material. With the use of laser beam we will be machining the material, that's why it is called as laser beam machining. Laser beam machining is a thermal material removal process that utilizes high energy coherent light beam to melt and vaporize particles on the surface of metallic and non-metallic workpiece. So laser light will be a coherent light which will be of high energy, and this coherent light of high energy will be used to melt and vaporize the particle on the surface of a metallic or non-metallic workpiece. Both can be melted or machined by laser beam machining. Lasers can be used to cut, drill, weld and mark. This is their utility in different industries. For cutting purpose, for drilling purpose, welding and marking purpose we can use laser beam machining. LBM is particularly suitable for making accurately placed holes. So wherever we want to drill a hole at a precise point, we use the LBM process. Now this is a schematic of laser beam machining. This is laser beam machining. Here you can see that how laser beam machining setup is like. This is the power supply source. This power supply source is connected to the flash lamp. See, flash lamp, one this side, one this side. Supply flash lamp. Once the power source is connected, switch on, the flash lamps are ignited, they are energized, and in turn they energize the ruby crystal or ND arc solid state laser. So once they energize this ruby crystal, what ruby crystal will do, it will generate a coherent light source, and there you can see in this coherent light source will be slowly, after some number of reflections, this coherent light source will be of high energy. So here you can see there is a 100% reflecting mirror and it is partially reflecting mirror. So the coherent light, which is after numerous reflections is getting energized, will not be able to escape from this side. So this way it will be able to escape from this side, which is partially reflecting mirror. So once it is passing through this mirror, what will happen, these coherent lights will be high energy coherent light will be coming out of this partially reflected mirror, and so this will be focused with the use of lens of certain focal length. It will be focused, and this will be focused on the tip of this coherent light will be focused on the workpiece, and this workpiece will be vaporized or melted to generate the required machining. Here it should be workpiece, it is missing, but workpiece should be somewhat here, and this coherent light will be fusing and vaporizing the material, will be vaporized. So this is the schematic of a laser beam machining. Now coming to next point, there are different types of laser beam machining. Lasers are used for laser beam machining. Generally, like CO2 pulsed or continuous wave laser, means CO2 gas is used as a laser material here for generating the coherent light source. So it can be pulsed or continuous. Generally, pulsed are used for drilling or discrete manufacturing, discrete machining, and continuous waves are used for cutting or continuous machining. So CO2 laser can be used. It is a gas laser that emits light in the infrared region. It can provide up to 25 kilowatt in continuous wave mode. So 25 kilowatt power can be produced in the continuous wave mode. So this will be, if continuous wave mode is generally used for cutting operations. Laser beam machining used for cutting operations, like to cut the doors of a vehicle from the main sheet. Second one is Nd:YAG laser, that is niobium doped yttrium aluminum garnet Y3Al 505012. Laser is a solid state laser. That was a gas laser. Now this is a solid state laser which can deliver light through fiber optic cable. It can provide up to 50 kilowatt. So it can provide 50 kilowatt of power in pulse mode and 1 kilowatt power in a continuous wave mode. So generally this laser should be used where we want to make discrete manufacturing, that drilling at different spots on a sheet. There it can be used, not for cutting purposes. So drilling purposes or certain other discrete manufacturing can be done with the help of Nd:YAG laser. Now application of LBM can be used to make very accurate holes of the size as small as 0.005 mm in refractory metals, ceramics. So these are hard materials and brittle material, while if you use conventional methods the brittle material would fracture, but with the help of LBM process we can make holes in a brittle material, and that too of very small size of the 1000 part of a mm, and in composite material without warping the workpiece. Continuous wave mode CO2 gas lasers are very suitable laser cutting. I have already told that continuous laser will be used for laser cutting. Here you can see this hole. This hole has been made by a laser. The SEM micrograph is being shown, hole drilled in a 250 micrometer thick silicon. See, the thickness of the sheet is so thin. It's 250 micrometer thick silicon nitride, and that this hole has been drilled or made with the help of Nd:YAG laser. So even for a very possible, so for delicate materials also we can do the drilling of very small size. This is the accuracy of this beam. It brings its utility. Now coming to next slide, what are the advantages of laser cutting? Advantage of laser, there are numerous advantages of laser cutting or laser beam machining. See, first one is no limit to cutting path, as laser point can move any path. So any contour can be made with the help of laser beam machining. There is no difficulty in making a complex shape on the sheet. For example, if you want to make a contour of this shape, that is possible with the help of laser beam machining. Second one, the process is stressless, allowing very fragile materials to be laser cut without any support. So stress is very less, and the fragile materials, which are very delicate materials, can be also machined with the help of this, because there is no fixturing requirement involved in the holding the workpiece. Very hard and abrasive material can be cut because laser generates a very high intense heat. Sticky materials are also can be cut by this process. So sticky material also can, because in conventional machining sticky material cutting is very difficult. It is a cost effective and flexible process. If you're doing the mass production, then it becomes cost effective and flexible process, because any type of manufacturing can be done with the help of laser beam machining. High accuracy parts can be machined. So accuracy, as you've already seen, in very thin sheets in a very small diameter holes can be made. No cutting lubricants required. There is no lubrication required, as in conventional machining it is required. No tool wear. Narrow heat affected zone is there. Very narrow heat affected zone is there, as compared to if we do the gas cutting, there is a very huge amount of heat affected zone. Very high width of heat affected zone is there, which is not desirable in any process. Now, limitation of laser cutting: economic on high volumes compared to stamping. So if you compare with the stamping is a die making process. With the help of stamping die we make the products. So stamping process is a process with the help of which we make the component, and similarly same component can be made with the help of laser cutting. So if we compare with both these processes, the laser beam machining is very costly as compared to stamping process. Limitation on thickness due to taper. So the taper, you can understand that if there is any taper, so it is not possible to take very deep holes in a material, because there will be convergence of rays, and see, like, once this is the lens and you are focusing the material on the rays on the material, what will happen when this material, if you want to drill a hole, so this there it will lead to a tapering action. So straight holes are not possible with the help of very large aspect ratio holes are not possible with the laser beam machining. High capital cost. So initial cost is very expensive, very much, because there are several units attached with the laser beam. A chiller unit is there, which is used to keep the laser beam unit cool, because a lot of energy is generated. So to maintain its temperature we use a chiller unit, that is a costly unit, and altogether it makes it as a costly setup. High maintenance cost is there. The maintenance cost is high. If the number of components are more, the maintenance cost is as a sophisticated process, so maintenance cost is there. Assister cover gap is required. So for like such a high temperature is there, so there is every possibility of oxidation occurring in the melting zone. So the assisted gas should be supplied to cover the exposed area in machining, so that oxidation doesn't occurs. So these are the limitation advantages of the laser beam machining. Now coming to electron beam machining. It is almost thermal unconventional machining process, and it is almost in a way analogous to laser beam machining, but here the energy source is different. So in what is electron beam machining? In the laser beam machining we were using coherent light source of energy packets, photons, were used to machine the material. Now in this electron beam machine we are using electrical energy is used to generate high energy electrons in case of electron beam machine. So here the machining will be done by high velocity moving electrons, as high as the velocity like 20,000 to 2 lakh kilometers per second. So electron beam is generated in a electron beam gun. So how do we generate electron beam? With the help of electron gun we generate the electron beams. I will be showing you in the next slide the figure, and there you can see how the electron beam is being generated. Electron beam gun provides high velocity electrons overall a very small spot size. So that means the intensity, the energy per unit area is very high in electron beam. So large amount of energy is focused in a very small spot size. Electron beam machining is required to be carried out in vacuum. So electron beam machining there is one additional setup is required, that it is conducted in vacuum. The workpiece has to be kept in vacuum so that the energy of electrons are not lost in open atmosphere. Otherwise the electron would interact with air molecules, thus they would lose their energy and cutting ability. Workpiece to be machined is located under the electron beam and kept under vacuum. As I already told you that the workpiece has to be kept inside vacuum. Electron beam machining. The higher and high energy focused electron beam is made to impinge on the workpiece. What happens? First the electron beam is generated and this high energy focused electron beam is made to impinge on the workpiece. The kinetic energy of the high velocity electron is converted into heat energy. As the high velocity electron impinges on the workpiece, these kinetic energy is converted into heat energy as the electron strike the work material. Third point, due to high power density, instant melting and vaporization start. As the intensity is high power, means large amount of energy is focused on a very small area, vaporization start. Finally, molten material, if any, at the top of the front is expelled. So the material which is on the top of the front of the electron gun is expelled from the cutting zone by high vapor pressure at the lower part. So that means the layer by layer, as the material as the beam is impinging on the work surface, so the energy is being transferred to the next subsequent layer of the workpiece. So the upper layer will evaporate and move out because of the just below layer which is at very high temperature and pressurizing the upper layer. And so in this way the next layer there will be machining will be done, and so the material will be vaporizing layer by layer. Due to high power density, instant melting, and third point, melting and vaporization starts. Finally, fourth point, finally the molten material, if any, at the top of the front is expelled from the cutting zone by high vapor pressure at the lower part. This I have explained you. Electron beam can also be maneuvered using the electromagnetic deflection coils. So electromagnetic deflection coils are there which are used for moving the electron beam to different area, or in the manner if you want to deflect the electron beam. So this can be done with the help of electromagnetic deflection coil for drilling holes of any shape. So if you want to drill a rectangular hole, so this can be done with the electromagnetic deflection coils that will help to move the electron beam to different coordinates. So that will be able to generate different shapes of holes. So this is the mechanism material in the beam electron beam machining. First, this is the beam, this is the upper surface of the material, this is localized heating by focused electrode. So first the localized heating is occurring. See in the second figure what is happening, there is gradual formation of holes, the material will melt and it will vaporize due to the lower material having pressure. So you can see that in the diagram there is a little bit of gradual formation of hole is there. You see in the third diagram you see, so this was the first, this was the second, this is third. You see the penetration till the auxiliary support. So this dotted are auxiliary support, and before that it is a material. So penetration till the auxiliary support is there. So if you are using electromagnetic coil, these will use to widen the hole because they can move the electron beam. Now removal due to high vaporized pressure. So you can see the material is being removed because of high vaporized pressure. So this is the mechanism of material removal in electron beam machining. Coming to next, you can see the electron beam gun over here. How is the setup of electron beam gun? So it is generally a cathode gun. You have already studied about the cathode gun in your elementary school. So here you can see there is high voltage lead is connected to cathode grid, and here it is anode. So electron will be generated and move from cathode to anode as it happens in cathode gun. So here it is valve, so the high voltage, and this will lead to the generation of electron, and this electron will be moving in stream. There will be generation of stream of electrons which will be constricted by these two valves, and this will be moving in this direction, a stream of electrons with high velocity. And now this magnet, there is optical viewing for viewing that how the beams are moving. There is a magnetic lens, there is a deflection coil. So magnetic lens will be used to focus the beam, this will be used to focus the beam, and this deflection coils will be used to deflect the beam to the required points or positions. So magnetic lens will be used to focus the beam, converging in fact you can say, and deflection will be used to move the beam from one coordinate to other. So and this is the work table placed on rollers. You can see here, here I can make you see. Okay, I'm showing you with the pen. Here it is the roller table, and here it is workpiece on the table, and this is the vacuum chamber. This is vacuum chamber, and vacuum pump is there which is creating a vacuum so that the energy of high speed electrons, high velocity electrons is not destroyed. So it has to be done in vacuum chamber. So this is the setup, how electron beam is generated and how it is maneuvered with the help of deflection coils. This work table is synchronized with the CNC machine so that we can generate the movement of table in x, y and z axis to get the different 2D or 3D shapes on the workpiece. Now electron beam process parameters. What are the process parameters which directly affect the machining characteristics in electron beam machining? Are the accelerating voltage, means how much voltage is being applied to generate the electrons. Accelerating voltage, the accelerating voltage will decide the velocity of electrons, and the high velocity of electrons will generate the kinetic energy, and this kinetic energy when impinging on the material will generate the heat energy. So directly accelerating voltage will decide the amount of temperature being generated. Beam current, simultaneous amount of beam current will decide the amount of heat being generated or the temperature raised of the material. If it is hard material, we have to use high accelerating voltage and beam current. Pulse duration, means if it is pulsating nature of machining is being done, what is the pulse duration? 1 second, 1 microsecond, 1 millisecond. What is the duration? Or 2 minutes, 1 minute, what is the pulse duration? Energy per pulse, means how much energy is provided per pulse. Power per pulse, means how much energy per second is being produced per pulse. Lens current, what is the lens current, which will decide the focusing of the electron beam. Spot size, what is the spot size of the electron beam. Power density, so power intensity or power density is the energy being focused on the per unit area. So these will be the process parameters which will affect the end output of the EBM process. If we vary any of these parameters, the electron beam process will be definitely produce some different result as compared to the other one. Now electron beam machining advantages. EBM provides very high drilling rates, so drilling rates very high, and when small holes with large aspect ratios to be drilled. So in laser it was a little bit difficult to drill the large aspect ratio holes, but in this large aspect ratio holes can be drilled because there is a possibility of maneuvering the electron beam. So means large aspect means when the L by D, length of the hole as compared to diameter, it can be greater. So length can be greater than the diameter, then thin holes, you can say thin holes of long more length are less large aspect ratio drilling. It can, second point, it can machine almost any material irrespective of their mechanical properties. So here my strength, stiffness, ductility is not a issue for the EBM process, as it applies no mechanical cutting force. Work holding frictioning cost is, there is no work holding frictioning cost as there is no mechanical force. So fragile materials, when this, so comes the fourth point, fragile and brittle material can also be resourced with the help of EBM process. The heat affected zone in EBM is rather less due to shorter pulses. So we are using the pulse nature, so the heat affected zone will be of very small size, and that is very good for the material. There will be no undue stresses. EBM can provide holes of any shape by combining beam deflection with using the electromagnetism and the CNC table with high accuracy. So any type of hole, square, rectangular, trapezoidal, can be made with on the workpiece, can be made with the help of electron beam machining. What is the limitation of electron beam machining? So electron beam machining, you can see the first point, the primary limitation are the high capital cost of the equipment and necessary or regular maintenance applicable for any equipment using vacuum system. So high maintenance cost and high initial setup cost are the limitations of the electron beam machining. And vacuum system is there, so it is adding an additional cost. In EBM there is significant amount of non-productive pump down for attaining the desired. What is non-productive pump down means? There is some time required to pump out the air from the chamber and create the vacuum. So this is a non-productive time which is occurring in the EBM process. So they making this process a bit more lengthy than its usual time. The heat affected zone is rather less in EBM, but recast layer formation cannot be avoided. Recast layer is the formation of vaporization of material, again depositing and solidifying. So this cannot be avoided even though the heat affected zone will be where the recast layer formation is there. So this was the two processes discussed, LBM and EBM. Hope so that you understood this process. So we will be discussing next process, PAM, plasma arc machining, in the next lecture. Thank you students for your valuable time.